So welcome back to the session. We have Dr. Roland Vijay with us to discuss about the scientific revolution which subsequently led to the industrial revolution in Europe. Roland, we were talking about the emergence of scientific revolution and the important scientists and their impact over Europe, especially in terms of providing an alternative explanatory paradigm. Now, can you briefly start with the transformation from this natural philosophy into specific sciences, and that led to the emergence of technology and its impact on industry? It's a large transformation, but could you summarize that?
First, if you don't mind, yes. I would actually argue against that.
Oh, so what so you would say that there's no linear connection?
There is no linear connection. Obviously, in hindsight, we can always create linear connections.
But usually that's how we understand, isn't it? There is science and then technology, and it leads
to but if you look really at least in the as I said in the last class, science or the scientist as a person, as a profession, that has really arisen only in the 19th century.
Oh, okay.
And before, obviously, we can talk about philosophy, we can talk about natural philosophy, we can talk about experimental philosophy. And yes, if you go back to somebody like Francis Bacon, who would then not only talk about science as empirical science, but also science as useful science. And you would also have, throughout the Enlightenment of the 18th century, you would have scientific societies who would kind of reiterate that. So in the last class, I also talked about natural philosophers traveling around, collecting data, collecting also quantitative data, trying to have an influence on agriculture, for example, right? Like, and kind of modernizing what we would call today modernizing agriculture. There is this idea of progress, right? Like, and this idea of scientific progress and using kind of science to improve the world, right? Like, and improve technology as well. But if you look at it, if you look at the Industrial Revolution, I mean, historians of technology have and very much agree on that the Industrial Revolution was actually not driven by scientific discovery. Even though you had that ideology of useful science and science should be used for technological progress, you can say. But that was actually not the case. So if you look in the history of science, and this is surprising to a lot of people, if you look into the history of science as natural philosophy, and the history of technology, we would actually find out that technology used to be, which is very paradoxical at a place like IIT, I ask my students and they always say, technology is applied science, full stop. But in its origin, it's actually not at all. If you would look at Aristotle and Greek philosophy, you would say, first, the experimental method is not part of science. You are forcing the world to do something. Mechanics is not part of science. Mechanics is part of the arts.
Oh, it's quite interesting.
Because it's artificial. Like, mechanics is artificial, right? Like, it's we forcing nature to do something. That is actually technology. That would be one of the definitions of technology. We are forcing nature to do something. So technology, and we see that if you look at the protagonists all over the world, if you look at, for example, the Indian caste system, we would see the separation between the kind of sections of society, like the Brahmin caste, for example, and the artisans, right? Which in the Indian system are much lower in the caste system, who are actually responsible for technology. Right. So there was actually a distance between science and technology. Also, I mean, who expresses this probably best in Europe is really Leonardo da Vinci as an example, because we look at Leonardo da Vinci as obviously a very gifted engineer, if we would say that with modern words, and at the same time a very gifted artist.
That's true.
Right? Like, and a lot of people describe Leonardo da Vinci as a scientist. He was not a scientist, and this is really also the kind of mechanics and the kind of design, also the kind of, you can see, anatomical drawing he has and all that. So we really see the kind of link between the arts and technology. And we also have this in English language if you talk about artisans and arts and craft. Right? So you can say historically, technology has been much closer to the arts than
surprising
to the sciences, right? And the Industrial Revolution also, if you look at the protagonists of the Industrial Revolution, it was much more this traditional trial and error, technical thinking, James
Watt,
for
example. Not coming from the high theory kind of thing.
No, not coming from the high theory thing. It's also very interesting. We have one of the very interesting people to read here would be, oh God, now I have to think and then we have to cut again. Edgar Zilsel. Edgar Zilsel, who has been writing a very interesting book already in the 1930s, where he puts up the hypothesis that the scientific revolution actually didn't emerge from abstract thinking, but much more from technological practitioners. And that technological practitioners actually gave inspiration to scientific abstraction. So scientific abstraction actually, and he also brings up, and this is again a very, very sociological theory, that actually modern science as we know it today, this is a thesis, did not arise earlier because earlier societies were slave societies. And basically manual labor was given to the slaves, and the ruling classes would never engage in manual labor. Right? And it was actually manual labor and the engagement with manual labor, and specifically you could make an argument, people have made an argument, if you look at Holland, for example, where a lot of these people, so you had like the craft guilds, where actually their status, I mean specifically if you look at arts and craft in Germany, and the status of class guilds in city societies. We were seen as free societies, if you think the idea of the citizen, right? That they were very much kind of giving inspiration for like creating or transforming useful or using technology as an inspiration for scientific abstraction. So if you look at the Industrial Revolution, specifically in Britain, and in Britain you can say up to the end of the 19th century, there was a big distance between engineering and the practice of engineering and science, really. It wasn't really coming together in the same way as in other countries. So in Britain actually, James Watt, who invented the steam engine, but even like earlier versions, the Newcomen engine, which had been around before. So if you look at the driving forces for the Industrial Revolution, and we can make out several of them, science was actually not one of them. So what happened really, so we have this saying by historians of technology, science owes more to the steam engine than the steam engine owes to science, is really the steam engine came up, but that actually led to, that motivated really research in thermodynamics. You can say there's a lot of research in thermodynamics that was inspired by the steam engine. And this is really, if you look at the complex relationship between science and technology, obviously, in many ways, even today, technology is a driving force for science as much as science is a driving force for technology. So you can say this also happened really during the time of the Enlightenment and the French Revolution. Obviously what we're having here is the Industrial Revolution starting in Britain, where this kind of ideology of bringing science and technology together wasn't really that strong. Whereas in France, you have this very much, with the kind of way how, you can say Newtonianism then moving from Britain to France and developing a very different kind of understanding. And also the states playing a very different kind of role. So in France you have...
During the Napoleon period or after that?
Even before with absolutism in France, right? Like you have a very centralist state. And the very centralist state takes a very strong role in the organization of science and actually also the organization of science and technology. So we get a very new model of relationship between science and technology, which I would say at the beginning is not grounded in empirical evidence that there's a relationship, but rather as an ideology how technological shift ought to be made. So we have specifically the foundation of these grand écoles in France, and specifically the École Polytechnique. We have a number of French military engineers. So a lot of these people, this kind of French mathematical physicists, a lot of these people were actually military engineers. So we have, for example, Coulomb, with the Coulomb law, which is one of the fundamental laws of electricity, right? Like it's really, if you look at the rise of electricity or electricity and magnetism, right? Where you have the inverse square law, which describes which is really modeled after the gravitational law, right? Like that the forces between electrical charges are central forces, and the structure is essentially the same as in gravitation. Coulomb was a military engineer, and he was concerned with the problems of saving powder storage against lightning. So how do you build a lightning rod, right? And the idea was, if you really want to understand this, you have to do research of its fundamental scientific principles. And I would say the Coulomb law was very successful, but it wasn't necessarily to begin with very successful to build a lightning rod, right? So to begin with, you can say this was more a kind of ideological model, but throughout the 19th century, obviously the situation or the relationship changed. So the relationship between science, there is a certain historical development in the relationship between science and technology, and this is also, and you can see that very well in the 19th century, specifically, as I said, there was no strong connection between science and technology in Britain. And what you have is, latest from the mid-19th century, the start of a British decline debate. And part of that is related to, so you have the first phase of the Industrial Revolution, which lasts like until the 1850s, right? Like, and then you have a second phase where other countries than Britain are much more successful, specifically Germany, right? Like, and the rise of the chemical industry, and you can also say the rise of the electrical industry, and but then also obviously railways and other and other things, machine tool making and these things. But what was very specific, both about you can say the chemical industry and the electrical industry, that they were very much science driven. So you can say in the first phase where you have like a rise of steel production kind of from bottom up, you can say what would be the scientific disciplines, metallurgy, for example. That actually came much later, right? Like in chemistry, that came, metallurgy came much later. So it was much more trial and error to bring up new melting processes, new steel producing processes. The steel engine, also the spinning jenny, and the mechanization of spinning and then weaving, scientists were not that much involved in it. But then specifically, if you look at the electrical technology and electrical industry, there was no, you can say, traditional arts and craft precedents to that, right? Like, it was entirely based on new scientific discoveries. And people taking these scientific discoveries, not necessarily understanding. There's still not a very linear relationship between scientific discovery and industrial production, but obviously all these are based specifically on Faraday's experiments, electromagnetic induction, Volta's discovery of the electric pile and electric battery, Galvani's experiments. So there was a lot of scientific experimentation and also scientific theory going along with that experimentation. That was very important for the rise of the electrical industry, right? Which is very different. And chemical industry, we can say, yes, obviously there's predecessors to chemical industries. I mean, people have been making soaps, have been making chemicals all the time. But the kind of rise of analytic chemistry, specifically in Germany, and using this kind of analytic chemistry, which came up after Lavoisier and this kind of chemical revolution, in order to synthesize new chemical compounds, and on that base a kind of industrial development. I mean, specifically if you think about the charcoal industry, chemical dyes, which again had a huge impact on India, right? Like if you think about indigo and the decline of natural dyes and the rise of chemical dyes.
Now, coming back to the social implications of Industrial Revolution, we know that as a student of sociology, we are trying to understand how this large transformation of the very economic fundamentals of a society from a feudal agrarian to a capitalist industrial society, that is something very, very significant.
Yes.
So what would be your observations on the social implications of especially people who migrated large scale to the cities and the rise of urbanism, the slums, the kind of chaos that followed?
First, I would say obviously industrialization has been a very, very long process. It started in the 1750s, and we would say places like India it's still ongoing, right? And we can still say certain sections of society or certain sections of our productive sector. If you think about agriculture, right? I would say, for example, even in Germany, industrialization and increasing industrialization of agriculture is still ongoing, right? And also criticism of industrialization. If you think about meat production, for example, in Europe, right? So industrialization is still, and we talk about the first, second, the third, and now, we talk even about a fourth phase of industrial revolution. Obviously, we have many social transformations and the rise of new classes, right? Like obviously the rise of the bourgeoisie on one side and the rise of the proletarian of the workers, and the rise of urbanization of cities, which came along with a very new mode of production, and obviously also with a very new way of describing economies with capitalism as we know it today. And yes, this has been very much linked also, if we come back to science in the 19th century, if we think about the scientist as a kind of professional idea, right? Like both the scientists or the scientific community is part of this kind of new rising bourgeoisie, and the idea of the scientist as a profession, right? And in technology, yes, we have, as I said, we shouldn't be understanding that. I mean, the impact of the steam engine, for example, right, which was invented already in the mid 18th century, was much stronger in the 19th century, right? Like, so it took some time before it would really take on. Also, if you see the rise of cities and city populations, if you go to British cities, yes, it would take on very early on in cities like London, Manchester. Then the spread of this was rather slow or not very even through Europe as well. Belgium would be one of the first European cities, but then also France, Germany, where industrialization would take on, right? Like, and then, as I said, would also go over from into new types of industrialization, right? I mean, one of the biggest impacts, if we look, for example, on transport, right? Like, but also on communication, right? So if we think about transport, we would then also look rather at the second phase of the Industrial Revolution, and we would look at the railroads. For example, the railroads and the steamboat as well. If we think of increasing global trade, for example, right? Like, and also you can say a contraction of space. And here I'm not talking about Einstein's theory of relativity, but much rather like how space in a social in a social way got very much contracted, and also time really changed. I mean, if you think about the telegraph, for example, right, as a means of communication, suddenly you could actually communicate instantaneously, more or less, with all parts of the world, right? Like, which then had a big impact on markets, for example, right? Which really changed perceptions, but even realities of time and space, right?
Yeah, that brings us to the very important question about the connection between Industrial Revolution and colonialism.
Yes.
Do you think Industrial Revolution would have taken place in Europe without colonialism?
Not in the same way. Certainly not in the same way, because basically, yes, the kind of trade, the way how trade was organized, and specifically how the British organized trade in their empire was a very central element of the Industrial Revolution. But if we really understand this as a system, obviously you cannot remove one component and think that wouldn't impact the system. So obviously, specifically, if we think about one of the main driving forces, or one of the main first sectors that really got mechanized, got industrial, was the textile industry, and that was very much depending on colonial trade, on also slave labor, obviously in the colonies, on cotton production, and also on colonial markets as markets for
because colonies provided both the raw materials as well as the markets for the finished products.
Yes. And if we specifically in India, where we had India as actually one of the main exporters of textiles, and that has been known since, I mean, you can go back into antiquity, right? Like the market. So you really have this kind of very new mode of production here coming in. It would be very difficult to say, but then obviously colonialism has a longer history than the British colonial empire. Obviously, we in India, we usually understand colonialism as kind of the British colonial empire, but obviously there's a longer history to that. And there have been different modes of operation how to run your empire. Obviously, there has been this kind of coming together. I would even say also this kind of relationship between science and technology. As I said, it's not really that easy, right? Like if you go back to Baconian ideas, you already have this idea that scientific knowledge should be useful knowledge, and the kind of idea of scientific societies in the 19th century, and as I said, the kind of French model of bringing science and technology together, which happened at the same time as the Industrial Revolution unfolded, right? Like, and we should not imagine. Obviously, the French Revolution is a different type of revolution than the Industrial Revolution. I mean, the Industrial Revolution, like the Scientific Revolution, if we even want to use these terms, and a lot of historians have criticized these terms, have not been proclaimed revolutions, right? Like by actors having said, "Oh, we topple over the old regime," right? Like, and they rolled out what is also typical for these revolutions. They rolled out over a much longer time period. Only in hindsight. In hindsight.
Especially French Revolution did not really succeed in that sense. No?
Yes. So. Only in hindsight, we would call, for example, the Industrial Revolution a revolution, right? Like where I still very much, even though a lot of people have questioned the notion of the Industrial Revolution, but I think the Industrial Revolution is much more. We have a much stronger argument to call that a revolution than the Scientific Revolution. Actually, the Scientific Revolution you really see has kind of unfolded over a period of several hundred years, right? Whereas the kind of effects, I mean, specifically if you look right now, as I mean, one of the biggest indicators of industrialization has been for the longest time, in many ways still is, and it's part of our problems of battling climate change and the paradoxes of what we would call sustainable development, right? Like where we talk about growth on one side, and this kind of idea, and this comes really with this kind of idea of progress that comes in this period. And if we really see, okay, when do we really start having larger amounts of carbon dioxide in the industry, we can really point out at the point of the Industrial Revolution, this is really the starting point where things really very much change. And also our kind of impact on environmental factors very, very much start, right? Like, and where we look at this kind of increase of energy production, right? Like that has, for the longest time, really been kind of a direct indicator of industrial development, right? Like, and we're struggling to get away from that, right? Like specifically in India, a country where we still have large percentages of population who, for example, not connected to electricity, right? So this kind of idea really, and I think this is again, if we want to look at where do all these kind of transformations and revolutions come together, is really kind of this idea of which again today has been much criticized, the idea of modernity,
yes,
right? Like this kind of idea, modernity as an idea took shape, right? And also this idea of, instead of having a more static understanding of the world, to have an idea of some kind of progress, right? Like
absolutely.
whether that's linear or in any other shape, right? Like, but this idea of progress that's taking shape, right?
Yeah, we identify all these revolutions as coming together, producing something called as a modernity, which actually promised you better, control over the natural resources, better control over the nature.
Yes, yes.
And it promised you that human condition would be better, it would emancipate. But
Yes,
now, when you look back those promises, we realize that many of these promises were quite problematic.
Yes,
and we are finding ourselves in a very difficult situation.
Yes. Obviously, we can say yes and no.
Yeah.
I mean, one of the things you would really have after the industrial revolution is a very strong population growth. Right? Like we can say yes. Obviously, we have improved living conditions.
Absolutely.
We are able to kind of place many more humans on Earth. Also, we can say in many ways conditions have improved. If we think about mortality,
everything. But quite a lot of the argument is quite a lot of unintended consequences. Consequences that we did not really anticipate. That they have emerged as major things that we are yet to learn to deal with them.
Yes. And obviously we have talked about colonialism as well, right? Like the whole colonial experience where a lot of indigenous populations have been extinct, right? Like extinct if you look at the Americas, but also if you look at if you look in Africa, genocides that have happened through colonialism, and also specifically, I mean, we also talked about the ideas of Darwinism, right? Like that the rise of humanism was something that raised, if you look at the French Revolution, the ideals of fraternity, equality, liberty, right? That weren't in any way extended to the colonial world, right? Like that, so with the kind of humanization, specifically if you look at natural philosophy throughout the 19th century, I mean, and that has been for a very long time. I mean, if you look at natural history museums, until rather recently at the Smithsonian in the US, for example, where indigenous populations were placed as part of the natural history rather than as part of humanity, right? So there was a lot of exclusion, or the kind of the extension. How much was that kind of promise of equal opportunities for people really really extended? And obviously we could we don't only have to look at that. We can look at gender equality, for example, and that has obviously been a rather recent phenomenon, right? Like that women actually were even considered to be eligible to have equal rights as men, right? So obviously there were strong limits to that, and if you look also at specifically at the 20th centuries, there are two large blows actually to the whole promise of modernity, which are called the First World War and the Second World War, right? Like where we can say, okay, all our scientific and technological advantage, the only thing we are using it to is to kill each other more efficiently, right? So obviously these have been rising
concerns and
obviously, and also criticism of this kind of idea of progress and modernity through also through industrialization, right? Like specifically, if you look at science and technology, obviously they've made a huge impact on warfare, right? And an impact to make wars more deadly and prolong wars
more
also.
Yes. More deadly, more lethal.
Yes.
Yeah, so thank you very much. We are winding up the session.
Yes.
Thank you, Roland, very much for providing us very useful insights, especially on this connection between science and technology.
Yes.
Because usually it's taken for granted that science led to the emergence of technology, that led to the emergence of industrial revolution. And as a historian, you really problematized it, you made it more complicated.
Yes.
So
yes.
Thank you.
Yes,
thank
yes,
you very much.
yes. The relationship between science
Yeah,
and technology
yeah,
is a very complex one, and we also have to historize it.
Yeah.
We really have to understand the kind of changing
Yeah,
relationship, and specifically if you look at modern times, if you take at our time again, you can say the relationship between science and technology has taken a different turn, which is usually expressed in the term techno-science, right? Like where we say that science and technology have kind of come together, at least to certain types of science and technology have come together to a kind of seamless web. And one more thing also, there's been a very important, or for the historiographical debate, a very important book by David Edgerton, The Shock of the Old.
Okay.
What we should really be thinking about the relationship between science and technology. Old modes of production have never really disappeared.
Oh, okay, yeah, correct.
So we still have craft.
Yes.
We still have craft technology, and we still have a lot of technologies that are with us since the beginning of humanity. For example, we still use hammers, right? Like we still use hammers, and a hammer is technology. And we can say, yes, we have been using hammers as humans. We've been using hammers since Stone Age, right? Or other kinds of technologies, baskets, for example. We have been using baskets since Stone Age, right? Even though hammers are easier to find remains of. That doesn't mean that the hammer we're using today is the same hammer as we were using through Stone Age. But the problem that we have a lot of times looking at technology, we only understand technology as the kind of newest technology, right? Whereas obviously technology and the interaction of technology with society is rather complex, and we shouldn't only be looking at the kind of high tech, the kind of newest technology, which can be obviously today very much described by the term technoscience. So technology is a much broader concept, really, and still there is a lot of artisans in the world, right? A lot of craftspeople in the world, and we still have the kind of craft mode production in the world, together with industrialization, with industrial production.
So thank you very much.
Yeah,
thank you.
You're welcome.